Being the largest optical telescope in orbit, and thanks to the high-resolution and high-sensitivity technology that it possesses, it is able to observe things that the Hubble Space Telescope is unable to see, since these things are too distant and too long in the past. The James Webb Telescope has just sent the first ever image of another living world. According to recent findings, the James Webb Space Telescope has discovered the 4 galaxies that are the farthest away from Earth that have ever been found. One of these galaxies had its beginnings just 320 million years prior to the Big Bang, when the universe was still in its infancy. Since it started functioning fully a year ago, the Webb telescope has been responsible for a deluge of new scientific findings. It has been able to see deeper than ever before into the most remote parts of the cosmos, which also implies that it is gazing further back in time. By the time it reaches Earth, light from the most distant galaxies has been stretched by the expansion of the universe and migrated to the infrared section of the light spectrum. The NIRCam sensor that is housed on the Webb telescope possesses an incredible capacity to detect this infrared light, which enables it to swiftly find a range of previously unseen galaxies. Some of these galaxies have the potential to revolutionize scientists' knowledge of how the early universe functioned, and recently, the James Webb Telescope has just sent first ever real image of another living world. In 2 publications that were just published in the journal Nature Astronomy, astronomers made the announcement that they had unambiguously detected the 4 most distant galaxies that have ever been observed. More than 13 billion years ago, when the universe was only 2% of its present age, the galaxies began to form between 300 and 500 million years after the Big Bang. This is when the universe was only 2% of its current age. This indicates that the galaxies are from a time known as the Epoch of Reionization, which is the period of time during which it is believed that the first stars created. Immediately after the cosmic dark ages that were generated by the Big Bang, the time in question began. A variety of proposals that are supported by credible evidence have been put forward by scientists to explain what came before the Big Bang. One of these is called the Big Bounce. The Big Bang theory proposes that our universe is part of a larger cyclical process in which an earlier universe had an explosion into a singularity and then reformed into a new one after some time had passed. It's possible that the cycle went on and on for an infinite amount of time. The huge bounce might have been caused by a number of factors, including quantum processes, gravity, or spatial dimensions. The egg-parodic theory states that the cosmos came into being as a result of the collision of 2 brains, which are defined as tiny sheets of matter and energy that are found in higher dimensional areas. The collision resulted in a sudden surge of inflation and fast expansion, both of which helped to even out the conditions in our universe. On July 12th, at a live event, NASA made the first scientific photos taken with the James Webb Space Telescopes available to the public for the first time. Among these were the breathtaking Southern Ring Nebula, the cosmic cliffs in the Carina Nebula, Stephan's Quintet, and an investigation into the atmosphere of the hot gas giant exoplanet WASP-96b. On February 11th, NASA shared with the public the very first photos of starlight that were captured by the James Webb Space Telescope. The first shot that Webb ever took was of a star designated as HD 84406. The light from HD 84406 was captured by Webb's 18 mirror segments, which are positioned on the primary mirror. This resulted in the creation of a mosaic consisting of 18 distributed brilliant dots. According to statements made by Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate, on Twitter, these 18 dots will eventually combine to form a single star. After the various parts of the main mirror have been correctly aligned by the observatory, the process of image stacking will then begin. This will result in a single, unobstructed image that consists of 18 photos layered one on top of the other. The sunshield is both an infrared telescope's one and only redeeming quality, as well as its deadly fault. The immense leaps we've made in our comprehension of the cosmos have been matched by equally great leaps in the development of the James Webb Space Telescope during the past 3 decades. This is largely due to Webb's ancestors. The Hubble Space Telescope made the startling discovery that stars, galaxies, and supermassive black holes all existed considerably earlier in the history of the universe than was previously believed, and that all of these objects had undergone major transformations since that time. We now understand that dark matter and dark energy are the primary forces shaping the cosmos. With the assistance of the Kepler telescope and other sensors, we have made the discovery that galaxies are adorned with a broad variety of planets, including billions of potentially habitable planets in just our own Milky Way. These findings have led us to the conclusion that galaxies are filled with life of some kind. The James Webb Space Telescope has the potential to provide some of the answers to the issues that have been raised as a result of these discoveries. In the same vein as with past telescopes, scientists are hoping that observations made with this one may lead to new lines of inquiry. Mather made the observation that every time we develop new technology, we receive a surprise. The question of whether or not the cosmos had a beginning, or whether or not it had always been this way, may be said to have been the most important one throughout the most of the 20th century. J. Gallagher, an astronomer and professor emeritus at the University of Wisconsin in Madison, asserts that the compelling logic was simplicity for the British cosmologist Fred Hoyle and other proponents of the latter steady-state hypothesis. Gallagher is a supporter of the steady-state theory. Why was it necessary for there to be a period in time when something shifted and the universe had to start producing stuff? Hoyle, a proponent of steady-state physics, asserted that the impact of the Book of Genesis was what drove his opponents to believe in the Big Bang, as he referred to it. The James Webb Space Telescope, which is operated by NASA, has been responsible for the making of yet another long-awaited discovery in the realm of science. This time, scientists investigating the origins of Earth's abundant water used the telescope to make their finding. With the help of Webb's NIRSPEC, near-infrared spectrograph instrument, astronomers have made the groundbreaking discovery of gas, in particular water vapor, encircling a comet in the main asteroid belt for the first time. This finding provides evidence that water ice from the early solar system may be retained in this region. The finding of water, on the other hand, brings up a new mystery. In contrast to other comets, this one does not include any water. Even more surprising, there was a lack of carbon dioxide. Carbon dioxide typically makes up around 10% of a comet's volatile material, which is stuff that can be quickly vaporized by the heat of the sun. The research group has come up with two different hypotheses to account for the absence of carbon dioxide. There are a few possible explanations, one of which is that Comet Red formerly included carbon dioxide, but has now expelled it because to the increased temperatures. According to Kelly, since carbon dioxide may evaporate more quickly than water ice, it is possible that it will gradually disappear over the course of billions of years. It's possible that spending a significant amount of time in the asteroid belt was the cause. But Kelly hypothesized that Comet Reed may have originated in a part of the solar system that was unusually warm and utterly free of carbon dioxide. According to Heidi Hamel, a scientist with the Association of Universities for Research in Astronomy, AURA, who is also a co-author of the study and the lead for Webb's Guaranteed Time Observations for Solar System Objects, the next step is to expand the research beyond Comet Reed to examine how other main belt comets compare to one another. Webb now has the capability to observe these little, hard-to-find objects in the asteroid belt, which paves the way for us to draw conclusions about them. Does the absence of carbon dioxide hold true for any other comets in the main belt? Hamel believes that regardless of the outcome, learning the truth will be an intriguing experience. Be sure to subscribe for more mind-blowing information related to space that will keep you on your toes. Malam, who contributed to the study, suggests ways in which it may be implemented in the local community. It would be really intriguing to follow up on this discovery with a mission to gather samples and understand what else the comets in the main belt can teach us now that Webb has proved that there is water preserved as close as the asteroid belt. About 8 minutes ago, scientists made a groundbreaking discovery. In the next video, you will learn about this recent finding.